Okay, now we're going to look at some examples with implicit differentiation. You'll notice it's not just y equals and then a bunch of stuff. We have like a y to the fifth in here, mixed in here with an x squared and all kinds of stuff. Now it's asking us to find the derivative, and we're doing the derivative with respect to x. So we're doing this kind of derivative. So when we do the derivative of this piece, we're going to have to do a y prime as well. But that's good because we're trying to find y prime. So let's have a look. The derivative of the first piece is going to be 2x, and that's it. Derivative of the second piece, the 5 comes down. 3 times 5 is 15. The new power is 4, but we're doing d dx, and this is a y. So we're going to have to put a y prime piece here. Now don't be worried about that, because we need to solve for y prime, and now we have a y prime. So that's actually a good thing. Derivative of 10 is 0. Let's subtract 2x from both sides. Then we divide both sides by negative 15y to the fourth. Okay, that will cancel all of this stuff, and we just get y prime equals, negatives are going to cancel. Final answer, 2x over 15y to the 4. Okay, I want you to notice that our derivative is a function of x and y. So you don't just have to plug in for x, you also have to plug in for y. But that's our final answer. Okay, again, they give us this equation here. They ask us to find y prime of x. What they want us to find is the derivative with respect to x of y. So when we do the derivative of this piece, we just get 6x to the fifth. This piece is going to be the product rule, so we can let the first thing be 5x, and the second thing can be y. So we can do the first times the derivative of the second, plus the second times the derivative of the first. Now we'll do the derivative of this piece. The 3 comes down. The new power is 2. But we're doing d dx. And this is not an x, this is a y. So we're going to need an extra piece. We're going to need y prime. That's a good thing, though, because again, our final answer is y prime. So we're going to solve for y prime. Can't do that unless we have a y prime. So it's good that we have that y prime. Derivative of 6 is 0. Okay, this piece has a y prime, and so does this piece. So we want to leave those on the same side. We're going to want to get rid of this 5y. So we'll subtract 5y from both sides. We're going to want to get rid of this 6x to the fifth. So we subtract 6x to the fifth from both sides. This is going to cancel. This is going to cancel. Now, since both of these pieces have a y prime, we can factor out the y prime. We would be left with 5x minus 12y squared. Bring down the other stuff. Okay, to solve for y prime, I just need to divide by all this stuff right here. Okay, we divide both sides by that stuff. On the left side is going to cancel. Final answer is that y prime equals this fraction right here. Okay, I think most people can recognize this as just a circle. You have x squared plus y squared is equal to 10 squared. So it's a circle with a radius of 10. We want to find the derivative. So remember, that will be the slope at any point. You can see the answers are already down here. What I want you to notice is that the answer is a function of x and y. So you don't just plug in the x to get your slope, because you can see when x is 8, you have one slope that's negative and you have another slope that's positive. So you wouldn't just plug in x equals 8. You also have to plug in either y is 6 or y is negative 6. And that'll tell you the slope at that spot. Okay, you'll notice it's dx. So when I do the derivative of x squared, I just get 2x. However, when I do the derivative of y squared, I'm going to get 2y and then a y prime. Remember, the derivative of 100 is 0, because that's just a constant. Again, I'm trying to solve for y prime. So I need to get rid of all this stuff here. I'm going to start by subtracting 2x from both sides. Then I'm going to divide both sides by 2y. Okay, on the left side, everything cancels except for y prime. On the right side, the 2's cancel. And you're left with negative x over y. Again, this is y prime of x comma y, because you plug in x and you plug in a y to find the slope at that spot. So even though this equation is not a function, you can see we can still get the derivative. But the derivative may be a function of x and y. Okay, on the last example, we did the derivative of x squared plus y squared is 100, and we got negative x over y. Now here they want us to find the second derivative, and then on top of that, when we're done, we have to plug in 6 and 8. So we're plugging in for the x and the y. In order to do the derivative of this, we're going to have to do the quotient rule. Okay, when you do the quotient rule, you can put that negative either on the top or the bottom, or you could just leave it out front. Remember, it's a constant, so it's kind of like a -1. So I'm just going to leave it out front right here. It'll just be negative. And so really, I'm just doing the derivative of x over y. Okay, when I do the derivative of x over y, it's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom. The derivative of y is just going to be y prime, all over the bottom squared. Now, one of the tricky steps is we're going to have to replace y prime with this piece over here. Okay, we're going to put parentheses around it. Okay, after trading y prime for negative x over y, you can see it right here, I'm going to rewrite it as a second derivative like this, and I'm just going to rewrite it like this. So this is the second derivative of x comma y because you can still see all the x's and all the y's. But now I'm going to plug in a 6 for the x and an 8 for the y. Okay, there we go. And remember, if this is a free response question, you're just going to want to stop right there and leave your answer. Now, if it's a multiple choice, we're going to want to simplify a little bit further. We're going to multiply the top and the bottom by 8. Okay, that's going to give us 100 over 512. And the final answer is going to be negative 25 over 128. And if you look at that point, you'll notice that the slope at that spot is negative, so it kind of looks right. Okay, we're going to use the same circle, but it wants us to find all the points whose x-coordinates are 6. Okay, this is not a calculus question. You just plug in 6 for the x, subtract 36 from both sides, take the square root of both sides, we're skipping a few steps, but we end up with y equals plus or minus 8. So that means when x is 6, y can be positive 8 or negative 8. And you can see those points on the graph over here. Now down here, it wants us to find the slope of the tangent line at these points. So that part will be calculus. We'll plug in 6, 8 first. So when x is 6 and y is 8, the slope is negative 3/4. So that's the slope of the tangent line right here. When you plug in a negative 8, you end up with a positive 3/4 slope. So that's right here. The slope of the tangent line would be positive 3/4. Okay, we're going to use this same example. So it's the same circle with a radius of 10. It's asking us to find only the x-coordinate for each point where the tangent line is either horizontal or vertical. Now, to get a horizontal tangent line, we just need the top to equal 0. So we just need x to equal 0 in this case. Now, sometimes the top is a lot more complicated than that. In this case, it's just an x. Now, to get a vertical tangent line, you would need the bottom to equal 0. In this case, we just need y to equal 0. And that's it. There's really nothing else to it. Now, we do want to be careful. We want to make sure we answer the question. It wants to know what is the x-coordinate for each point. So for the horizontal tangent slopes, that's when x is 0. That's the y-axis. You can see the slope right there, and the slope right there is 0. So that's the right spot. The y value would be 10 and negative 10. So our 2 points are going to be 0, 10, and 0, negative 10. But again, it's just asking for the x-coordinate, so that's x equals 0. Over here, we don't have the x-coordinate. We know y equals 0 means you're on the x-axis. So the 2 points would be negative 10, 0, and positive 10, 0. So there was only one x-coordinate where you had a horizontal tangent slope. But there were 2 different x-coordinates where you had a vertical tangent slope. Now I wanted you to notice that we had a really easy example because all we had on top was just an x, and we were done. But sometimes you get something that's a whole lot more complicated, so you may have to solve it for x. Same thing with the bottom. We just got a y. It was really easy, but sometimes there's a bunch of stuff on the bottom. And you may have to set it equal to 0 and then solve.